of you have joined one of the best engineering colleges and have started to begin your journey as an engineer. And from now on, you should all wish to grow and develop into the qualities of an engineer, which are insatiable curiosity and an innovation and problem-solving mindset. And I'm proud to call myself a member of Edhitha, where each and every member is showing and is constantly improving on the above said qualities. In a world where engineering is a rat race and a way to the common form, the norm of the world, and called a useless degree in the Instagram reels, we at Edhitha are trying to prove them wrong and create an impact in the technical world. Edhitha, a word in Sanskrit that means progress and increment, reflects the kind of work we do in our lab. We are a multidisciplinary student team of RIT. We design and manufacture payload delivery mechanisms and autonomous aerial vehicles. Our integrative approach effectively draws skills from mechanical, electrical, and computer science. Being one of the oldest technical clubs of RIT, we welcome you to our college and to our clubs. I would also like to welcome our faculty advisor, Mr. Lokesh, and our club head, leader of our club, Nihal Jadidar, to give a small token of appreciation. I would also like to call up our members, Pranjal and Api.
Thanks, Yashas, for the great introduction.
Hi everyone, it's great to have you all for the orientation today. I'm Pranjal.
This is Abhinav.
And we thought before we get into the main agenda of today's meeting, let's have something fun for you. So we have a technical quiz planned out for you guys.
Let me lay down the ground rules for the quiz. The questions will be displayed up the screen. It may or may not have options. If you know the right answer, raise your hands. Don't shout the answer. Teammates will be on the lookout for you. If your answer is right, you'll get a reward. If your answer is wrong, we'll ask you to raise your hands again. And if you're not satisfied with the answer, we will disclose the answers ourselves. Hope the rules are clear.
Also remember guys, this is a technical quiz, so it's meant to gauge your technical knowledge in the fields of UAVs, drones, and a bit of basic physics as well. But do not shy away from answering. Even if you're not that confident, just go ahead and make a guess.
Are you guys ready for the first question? Who is Rihanna's boyfriend? Donald Trump, Jay-Z, A$AP Rocky, or Justin Bieber? Don't shout, raise your hands. Who's going? Sorry? That's the right answer. Can you hand him a award, please?
I see a lot of confused faces here. Don't worry guys, this was just a small prank. The whole quiz is not going to be about this.
Thankfully. On to the real quiz. Let's start. What is this type of UAV called? A quadcopter, a single rotor, octocopter, or a fixed wing?
The yellow shirt guy.
That's the right answer. You have a reason why. Can you tell me why? Sorry? That's right. There are 8 rotors. Octo has 8, a quad has 4, hexa has 6, and a single has 1.
Great. The next question, what's the control for up and down motion of a drone called? Yaw, throttle, pitch, or roll?
The mechanical rest.
Throttle. Yeah, your answer is absolutely right. You get a goodie.
Okay. Is the image shown here of a drone, true or false? Raise your hand.
Please don't shout out answers.
The one with the ash t-shirt. Yeah. Yes.
No, the ash. Do you have a reason why? Like why? Why is it true? Sorry? That's correct. But then, okay. Who was that? Okay. The full answer is yes. It's a drone, but it's also called an unmanned aerial vehicle. It's a common misconception that only multi-rotors are called drones, but no, even these fixed wings are also drones.
Come on, guys, you can clap for your friend then. He gets it right. The next question: what was the purpose for which the first ever UAVs were built? Well, that's close, but that's not exactly the right answer. Anyone else? Yeah, the blue shirt guy here. Surveillance is not right. Yeah, that's the right answer. Military purposes. So, UAVs were originally developed through the 20th century for military missions that were too dull, dirty, or dangerous for humans.
Okay, imagine a quadcopter. If the front right motor is going in the anti-clockwise direction, what should be the front left motor's orientation? Okay, that's right. Again, why? Why is it right? Do you have a reason?
Right.
Right answer.
That's the right reason and that's the right answer.
Both are
So
right
both of
answers.
you get good.
The answer is, as he said, to have a net angular momentum to be zero. So you have the motors, adjacent motors to be in the opposite orientations.
The next question. What is an FPV drone? That's not exactly right. Your two words are right, but one of them is wrong. Yeah, that's the right answer. So, first person view, also known as remote person view, is a method used to control a radio controlled drone from the driver or the pilot's point of view. So, what the drone sees is what the driver sees. And here you guys can see one of our team members. You'll find him there near the door. He has experienced an FPV drone too. So, yeah, moving on.
Okay, which country was the first to build UAVs? Your options are US, UK, China, and Israel. Israel is the right answer. Israel built the first ever UAV at 1973 as Panjal said, for warfare in the Arab-Israeli war.
What type of signals are used to communicate with the drone via transmitter and receiver? Infrared, radio, digital.
Black shirt, last question. Yeah.
Sorry, that's the wrong answer. Guys, please do not shout out the answer. Okay, since most of y'all just shouted out it's radio signals, that's the right answer, and no one gets a goodie for this.
What is meant by the payload of a UAV? That's the right answer. Payload here essentially means anything other than the propulsion systems and your frames.
How many UAVs which includes multi-rotors and fixed wings, do you think are there in Edhitha's lab? 3 is the wrong answer. 6 is wrong. Not 2, not 11.
Nice.
Okay. Sure. Okay, so the right answer is not close to anywhere you guys were guessing. It's 42. And yeah, you guys should visit our lab and come to see it. It's really cool. With this, we come to the end of our quiz. Let's have a round of applause for you guys because you all were terrific.
Let me call back Yashas to give a gist about our competition and our history in the competition.
Okay, by now all of you are aware of Edhitha. We are a multi-rotor club. We build fixed wings also. And I'm pretty sure you all know that we go to US for a competition. And now I'll be taking a few minutes to explain about the competition itself. So the competition is called Student Unmanned Aerial Systems, or SUAS for short. It was, and they have a very famous quote, bringing students education to real life. All of you have completed 10 years of schooling and 11th and 12th. And I'm pretty sure none of you guys have actually applied what you've learned. You just have a lot of marks, you've got percentages, and even entrance exams you've written. But where have you actually applied it? So this started in 2002, SUAS, and they bring students education to real life. So they have real-world design challenges where they expect students to work throughout the year to build an unmanned aerial vehicle that is fully autonomous and capable of fully autonomous missions. That is made for search and rescue missions. So many colleges from across the world participate in this competition since the beginning. And many notable colleges like DDU, IIT Bombay, IIT Kharagpur, even abroad in US where like Cornell University, even Harvard also. Many notable colleges take part in this competition. So they expect the students to work throughout the year to create an autonomous aerial vehicle capable of search and rescue mission drones and payload delivery. So So this is like the small mission requirements, like a very small gist of the requirements that the competition expects from the students. So the first thing you see is autonomous flight. So all the drones we have to build are supposed to be capable of autonomous flight. Autonomous as in the drone should be able to handle itself on its own. So a takeoff should be done by the drone itself. Following a certain path should be done by itself. Landing should be done by itself. Any payload release we do, it should be done by itself. Next is static and dynamic obstacle avoidance. Everyone knows what is obstacle avoidance, right? Like there's an obstacle and I should avoid it. So the drone itself should know when to avoid and identify what is the obstacle. Because let's say when the drone is flying and suddenly there's a pole or a tree in the middle, the drone should be smart enough to avoid it on its own. And that's where our navigation sub-team creates the brains. So there's another mechanical task, payload delivery. Like in the quiz, payload was asked. What is a payload? The extra material that's added on the drone. So a safe delivery, releasing of the payload. That's another thing the competition expects from us. Another thing called as ODLC, that's an ISC task. It's done where the camera on the drone should be able to take pictures on the ground and identify the targets. More information will be given in the next slide. So right now I've given a gist about the competition itself, and I'm pretty sure you realize what is the level of seriousness and what is the level of competition now. So now I'll be talking to you about the history of Edhitha with the competition itself. So born 2011, that's the first year in SUAS. We started off with a name called Lakshya. 3 mechanical students started building drones in an age where the drone technology itself was taking its first steps. Yeah, that makes us the oldest club. Another crazy thing about that year, when we went to our first ever competition, first time participating, we placed 3rd in the entire world. 2012, the next year, we were very confident. We won the award, Never Say Die Award, but we didn't get a rank. we had an unavoidable crash due to a police broadcast done in the nearby airfield that interfered with our communication with the drone and the ground station. So we had a crash. But don't worry, the seniors that overnight borrowed parts, did a lot of work to create a fully autonomous drone for the next day itself. They crashed, they built another one the entire night and flew it the next day. 2014, the Darwin project. I'm pretty sure you see this right now and be like, oh, it's just another drone that they purchased and just gave it the autonomous flight. But the Darwin project is where the students themselves manufactured an entirely new fixed wing. We ourselves created, tested, and started the manufacturing of a fixed wing plane. And that too, it runs on internal combustion engine. The next was Anaconda project. After 4 years in the competition, Edhitha, for the first time, got the first rank. Another crazy thing was we were the first Asian to win in the history of the competition. And 2016 we placed 5th in the internationally, first in Asia. And 2018 we started the Clean Slate project, 10th place internationally, 2nd in Asia. And only 4 members went to the competition. And 2022, we were awarded the Don Yeager Tenacity Award. Thank you guys. And now, you know what is Edhitha, you know what is the competition. And I would like to call upon Maurya to discuss about the technical aspects of the team, and I'm pretty sure you've all been waiting for that. So, I would like to hand it over to Maurya.
Thank you, Yashas. So, as you all know, it's Edhitha Unmanned Aerial Systems. When you talk about a system, you need an aerial vehicle to integrate your system. So, any one of you can guess the few unmanned aerial vehicles. Can any one of you mention few unmanned aerial vehicles? Yes? Just a type of the unmanned vehicle, not just the name. Okay. Missiles. Else? Okay, cool. What? Delivery. Delivery is a mission. I'm asking for unmanned aerial vehicle. Drones. Yes? Yes? Space exploration. So nice. A satellite. Wow, crazy. Yeah, helicopter. That's a nice answer. Yes? We have pilots in our club. You'll get to know in the future of this event. Yes? Gliders. Okay, fine. So, as you can see on the screen, these are the few types of unmanned aerial vehicles. As you mentioned, gliders, drones, helicopters, and the one in the middle is known as a fixed wing. Can anyone point out what's in the black and white? Yes, the Hindenburg incident. So basically they are called the airships, and you know what happened after the Hindenburg incident. So moving on to the next slide. What's in a hangar? Are you guys interested to know what planes we have in a hangar? Oh, that's nice. Electrical and co? A pretty huge number. And it's my branch. Mechanical? Yo. Civil? Chemical, biotech? Cool. I can see some hands. So, getting into the details of the unmanned aerial vehicles in our hangar, these were the planes which we have used in the competition where Yashas has mentioned. As you can see in the 2014 pic, it's the IC engine Dhawan project. And 2015, 16, 17, 22, it's called the Anaconda. It's the most loved plane of Edhitha. And so, what's up in 2023? There's no plane displayed here. So it's a secret you'll get to know when you are in the team. So moving on to the next slide, presenting you the structure and propulsion systems. This is the first sub-team where you are getting introduced. So what do we do in structure and propulsion systems? A decade of legacy, fixed wings. So for the past 10 years, Edhitha was using fixed wings. When you, whatever the unmanned aerial vehicle it is, the terms like pitch, rock, yaw, roll are common. So for the fixed wings, it's certain again. Aileron, have you heard about the control surface like ailerons, rudders, elevator and flaps? So what's the most common and important thing in all of these control surfaces? What do we call it exactly? Yes? Airfoil, exactly. Even you have answered. Nice. It's called an airfoil. So whether you take a fixed wing, a multi-rotor, whatever, the most important thing here is the airfoil. It makes up the unmanned aerial vehicles fly. So have you ever wondered like how does a drone fly? How does a fixed wing or a plane fly? It's the backbone of this airfoil. Just because of the pressure differences created between the bottom and the top of the airfoil. So if you're wondering how, have you heard about Bernoulli's principle? So airfoil is based on the Bernoulli's principle. So what I've said, airfoil is used in multi-rotors too. As you can see, there's a prop displayed there, the pink one. Even the prop is based on an airfoil. And do you think airfoils are used in a wind tunnel? You get it right? You can relate. Okay, and one more interesting thing. Are airfoils used in a Formula racing car? Yes, exactly. So, in an aerial vehicle, airfoils are used to lift up. Whereas in a Formula racing car, airfoil is used to push the vehicle down and have a speed turnings. So that's how important an airfoil is. So moving on to the next slide. I've said for the past 10 years we were using fixed wings. So what's the change now? Edhitha has a new innovation for multi-rotors. So what's the change? Why from fixed wings to multi-rotors? There's a reason for it. So moving on to the next slide. What do we do with multi-rotors in Edhitha? As my friends Yashas and Pranjal Abhinav has mentioned in a quiz, the opposite motors counter-attack to make the angular momentum zero and make it fly. The same airfoil concept. So exactly, what do we do in the structure and propulsion systems? The first thing is the frame design. So as you can see, a multi-rotor here, it's a quadcopter. So you need a frame for it. You have to build a frame. So from where do you start? You start with your mission. How much payload you require. Depending on that, you select the motor. From there, you get the specifications, the prop selection, what size. From there, you start designing the mounts for it, the base plate for it. After you design in softwares like SolidWorks, Fusion 360, and more, then you simulate them. You run thrusters on it. After that, you get it prototyped on a different material which is cheaper and friendly for you. So we build our multi-rotors using a carbon fiber. But we don't get the prototypes in the initial stage with just a carbon fiber. With birds, balsa, or whatever. And then, if everything is ready, after multiple iterations, your designs are correct, whatever dimensions you have given, they're aligning properly, then you go for the manufacturing. When you come to manufacture, if it's a case of carbon fiber, you CNC cut it, you laser cut it. So now your frame is ready. You just have the frame, there's nothing inside it. So what's next? Going on to the next slide, the propulsion systems. What do you mean by propulsion systems? Yeah, what do you mean by propulsion systems? The most important thing of a multi-rotor is the motor and prop selection. So how do you do it? Whatever motor you select and whatever prop you select, it varies a lot. Depending on the mission, whatever payload you require, how much endurance you require, you select the prop. Do you think if I keep my motor constant and change prop, will it be the same, the thrust provided? Yes, no, exactly. So, if I just change my prop, my thrust, endurance, my power consumption, everything changes. So, it's not like I have this motor, I'll change my prop. It doesn't work like that. So, there will be an immense calculations in the selection of motor and prop, maintaining your thrust to weight ratio. So, now your frame is ready, you have mounted the motors, propellers, fine. So, what's next? Can you guess? Exactly. I think you have gone through the slide, right? Thanks, Pratham. So it's like the power systems. How do you supply your DC power supply to your unmanned aerial vehicle? Yes? Yes, it's exactly. So we use lithium polymer or lithium ion batteries for it. So the one mentioned in the black is a lithium polymer battery. The one you can see at the behind with the blue cells is a lithium ion cells. So we do get the lithium ion cells, make the custom packs according to our required endurance with spot welding and so on. So there's a lot involved in making the power systems work. You have your mission. Now you know how far your drone must fly, with what speed your drone must fly. And it's not just that. Already your frame, motors, propulsion systems are ready. You must have the place to fit the battery. So according to it, you select the lithium ion cells, spot weld, and manufacture it. So what's the power consumption? How much amp it draws? You all run the calculations, choose the configuration of the battery, and then assemble it. So, till now, my frame is ready, motors are ready, props are on. I powered the battery. So who flies it? It's not just a pilot. Don't say pilot. Who flies it? Navigation team, flight controller. So Abhinav, there are some answers for you. So you have to take it on.
A little bit fun. How many Abhinavs are here in the crowd? Okay, please change your name when you're joining Edhitha. Okay, there's Abhinav 1, Abhinav 2, Abhinav 3 in Edhitha already right now. So please change your name when you're joining Edhitha, alright? So I am Abhinav Binagi from Aviation Electronics and Navigation Sub-Team. Today I'm going to tell you more about my sub-team and what we do. Aviation electronics, the word is quite self-explanatory. So we work on the electronic components which go on the drone. Alright, starting from procuring, selecting, testing, and setting up the electronic components on the drone, we do all those tasks. And these are some of the main electronic components which we use. And can you all name which is the processing unit of a drone, which is the main thing required for a drone to work? No, not Raspberry Pi. Exactly.
controller is the main processing unit of our drone. It's like the CPU of the drone, without which the drone can't fly at all. Alright? And then we have other electronic components like electronic speed controller. Where do we use the electronic speed controller? Yes, we use it to control the motor speed. And then a LiDAR. Yes. We use a LiDAR to measure the distance between the objects. And these are some of the electronic components. So, okay, now I've put my electronic components on the drone. Will it fly? What's required? Power is already done. I put electronic components. Aerodynamics is done already, alright? Yeah, testing, okay? So what happens is the drone is not like any other remote control car where you power it up and it starts going in a straight line. The drone needs a perfect training and tuning, alright? So we have to train the drone rigorously with some proportional integrated derivative values. That's called PID values. You will be learning all those in mathematics, I think in the first and second year, probably. A little bit of it. So we have to play around with the values and try to tune the drone as stable as possible so that it can be as stable as possible in the sky. Okay, now I've done the electronic part and I've done the tuning, so the drone is gone up. So what next? I have one question for you. How does a drone fly? Do you always need a remote control guy who's working in the remote control and the drone is flying? Or are there any other methods to fly a drone? Huh? Yeah, exactly. So we can do autopilot, and in Edhitha, we perform autonomous flights. Okay, we perform autonomous flights. That is, it can take off, do all the missions, and then land back all by itself without any human intervention at all. So, which picture is this? What is this here? So you all can see a quadrant here, right? So I've set my points here, and after just clicking a button, the drone can do everything all by itself without any help of the person handling the motor or handling the remote. So I've set my commands here, and we use softwares like Mission Planner and Man SDK to perform these autonomous tasks. And then one of the interesting tasks which we do is obstacle avoidance. Alright, the drone will be flying in the sky, and there might be many various objects like towers, poles, electric lines, birds, tall buildings, okay, which might interfere with the drone. So the drone can't just go and crash into it. We have to avoid those buildings, all those objects, and then the drone has to continue its mission by itself. So to do that, we do the obstacle avoidance in our sub-team. Okay, which is my sub-team? You remember? Okay, aviation electronics and navigation sub-team. So we do all that in our sub-team, and now the frame is built, electronic components are there, it's flying properly, obstacle avoidance, everything. So what next? Correct, the software. So my friend, Azhar Abhinav is going to come and tell you about his sub-team, alright?
Hey guys, lovely to see you all here today. So me, Satvik, and we have few more members. We're from the Imagery and Cyber Systems sub-team. Can any of you guess what we do? Okay, image recognition, mapping, data analysis, yeah, that's right. So we, as you know that the drone flies, and Yashas has mentioned that we detect targets on the ground. So we develop machine learning models that autonomously detect various parameters of the targets. We also use GUIs to make it easy for us to use, and mainly we try to scale it down all onto edge computing devices like Raspberry Pis or Jetson Nambas. Also, how do you think we capture our images from the drone? Okay, any guess on what type of a camera that we use? Video cameras? Any other guesses? GoPros? Okay. So for our requirement, we have to use very high standard industrial cameras. And one interesting thing that we do, it's not just software that we do here, not just coding, it's not just any other coding club or something. We want fun components, but we ourselves have a lot of fun components. And a lot goes into selecting these components, as they're very expensive and we have to compare a lot of stuff before we select the component. Okay. Coming to our computation requirements. So, as you target here, the triangle with the A in it. So many such targets are going to be laid across the field everywhere, and we have to identify the shape, the color inside it, and the alphanumeric character. Can any of you guess what size this target might be? Okay, palm size, that's close. Okay, so keep in mind that our drone will be flying at an altitude of around 30 to 50 meters. From that altitude, we have to detect this small object. Okay, so this is where our machine learning models come into play. And we also have to detect emergent objects like mannequins that are going to be placed everywhere. This is to simulate humans in real life. And to coming to how exactly we achieve all this, Sajid will continue from here.
Hey guys, I'm Satvik, and just out of curiosity, how many are first years here? Okay. How many are second years here? Not a single one. Okay. So, how many here are from CSE? Okay, I see a good number. Okay, cool. So, like Abhinav just explained, what are the competition requirements and what is required for achieving these tasks that are more than just having a flight controller and having an autonomous flight. So, I'll be giving you an overview of how we exactly achieve these kind of things and how we will be doing it with what onboard computers do we use, or do we use microcontrollers and all these things, right? And there's this common misconception where people think, okay, this guy's from CSE, now Pakka he'll be in this imagery and cyber systems team, right? That's not the case. At one point, we had more people from electronics in our computer science related sub team, right? So we are interdisciplinary. Now, getting back to the point, how do we plan on achieving this? So, before I explain how we do this stuff, I have a fun segment for you all. Right, so a bit of context. This picture was taken in 2016 in Maryland of the SUS competition from one of our planes that is in lab right now. Right, so I want a raise of hands on who can detect an object here, and what the object is a letter. It's inside a shape. I want you guys to tell me what the letter is, what the shape is, and what the color of the letter is, and what the color of the shape is. I want all four things. Don't shout out the answers. Well, what? Yeah, I know it's the E. What color is it? And the triangle? Okay. He's right. It's the letter E in a triangle that's yellow color and it's black. Moving on. Okay, if that was quite simple, can anyone find the target in this image? I want all four things. I don't want just the letter or just the shape. Okay, that black shape. Okay, and the shape? What? No. Black? No. I haven't heard the right answer from anyone till now. Just go ahead. It's a star. You probably can't see it right now, but our onboard systems must be capable of detecting that. And how do we do that? So this is a basic diagram I just made in like 2 minutes. It's a bit childish, but yeah. So what we do here is, there's the drone, and our drone has an onboard computer, right? An onboard computer can be a Raspberry Pi, a Jetson Nano. We have all those things in our lab. What we have to do is embed them or code them such that they work how we want it to work. And how you guys thought while looking at that image, okay, this is a letter inside a shape, that must be exactly translated into the microcontroller that's present inside our Raspberry Pi, right? And it's not easy doing these things, but it's definitely a lot of fun, because you runs on the onboard computer, and we have antennas, high bandwidth antennas. That means they can transmit not just data, but also, high bandwidth data like images and videos and stuff like that. And our the part of the job of the ICS sub team is to get all this right. And like you guys can see, the spotlight corresponds to the camera, the brain corresponds to the Raspberry Pi, and the ambulance corresponds to the bottle and a servo motor there. So can anyone tell me what this exactly is? Right, who got that right? Yeah, he's right. It's a payload release mechanism, like how Moria was talking about, and the structure and propulsion system builds. So we have to integrate with them. We can't just sit on our laptops and just stay away from all the other sub teams. We have to integrate, and it's not an easy task, but it's definitely very interesting. And and this is a kind of a flowchart of all the devices that we really have in lab and we are working on. And is there anyone I'm sure when I was in first year, I was like, oh, I've come to college now, I want to learn coding, full displacement, that placement I want. Is there anyone here who's interested in coding and stuff like that, like being tech savvy? Right, see. Yeah, I see a lot of people. So, in our team, coding is a major part of our work, but also, I wouldn't say it's like 90%. It's like 70% of our work. And the rest, 30% goes into just getting your stuff together. And like, if I just give you a Raspberry Pi right now, but you know the depths of Python, but you do not know how to do it on a Raspberry Pi, then what's the point? So, you are supposed to be tech savvy when you are in the ICS sub team, but you don't have to be it before. You can obviously come, learn how stuff works, and get a lot of insight into it. And so that's about it from my sub team. I'll hand over the mic to Yashaswini now, and she's going to go on of what's next. Thank you.
Hello guys, my name is Yashaswini. I'm from Structure and Propulsion Systems of Edhitha. So far you guys got to know about the different sub-teams of Edhitha, technical teams, Structure and Propulsion team, which explains about what we do, that is designing and fabrication of UAVs. Next is the Aviation, Electronics and Navigation, which is responsible for the autonomous flight and obstacle avoidance. The next most important part is Imagery team, which is responsible for recognizing the image processing, data transmission, etc. So what's next? The next requirement for the competition is release mechanism. According to our competition, it is required for us to drop a payload which is given to us to the specified target which is recognized by the IT sub-team. So you can see a target. It will have a shape, color, and the alphanumeric. So IT sub-team is responsible for identifying that target, and the bottle which you can see on the left side is the object which is to be delivered on that specified target. So for that, what do we need? We need a release mechanism, right? So yeah, you can look at the videos. These are the designs done by us using different softwares like Fusion 360, SolidWorks, and all. These are the different designs. We'll make the prototypes and actual models using different mechanisms, like we'll use 3D printing. That side you can see a laser cutting. Yeah, next important part is testing. You can guess where is this? Which place is this? Yeah. You can see the testing, which is very much required to test how our system works and to modify if required. And not only for the competition, we have even applied our skills in various fun activities, like we have done flag hoisting and other applications using our release mechanism. So you can see a video.
yeah, the last clip was in CM's event where Team Edhitha was invited for flag hoisting in the presence of News 18 channel. We were honored by CM in his presence. So yeah, that's about the technical teams of Edhitha. Now I'll call upon Pratham to explain about the marketing and studio teams of Edhitha.
Hi guys, I'm Pratham. Just out of curiosity, I want to ask you guys that how many of you guys are interested in entrepreneurship and stuff? Very less. That's sad to watch. Anyway, I'm going to explain to you guys about sponsorship and studio sub team and what are the tasks that we accomplish in the team, right? Video and photos editing. So that's pretty self-explanatory, I guess. So why do we have to edit videos and photos? That's the question. So we have to edit videos. Well, one of the most important video that we're going to be editing is going to be the FRR. It's called the Flight Readiness Review. So it's basically nothing but the proof. It's a proof of flight that, okay, so for the judges in US, internationally, who are going to review us, okay, they're going to say, okay, do you have a proof of flight? Yes. And that is the FRR. So, and the photo editing part is obviously for social media and other places to be used. Not only videos and photo editing, we're also going to be doing some posters and banners and flyers which are going to be used for marketing and promotion and stuff. Next, moving on to content management. So obviously, if we are going to edit a beautiful video, how are we going to do it without a proper content, right? So content management is just as important as editing videos and stuff. So you guys, so what we do is we make sure the content that we have recorded, maybe photos, videos, they're stored safely somewhere, and it's easily accessible for us when required to be used. So moving on to the next slide. Sponsorship. Okay. So sponsorship is, first of all, Edhitha is a student-run team. If you guys know by now, you would know that it's a student-run club. So we rely heavily on funds from companies. These companies are mostly international. So that means they're overseas, and so sponsorship is nothing but you being in contact with them, basically communicating with these companies to make sure they provide us with any form of support. It might be monetary, it could be technical, it could be in form of components. So what these companies expect from us is constantly giving them updates about our progress in the team that the technical team is making. It could be email writing, maybe you would write emails to them, or it could be other forms of communication as well. So sponsorship is one of the very crucial and important tasks that studio and studio sub team would be doing. So moving on at documentation. So as you guys know, we in school we would have studied history, right? So history is nothing but a piece of evidence that some event has occurred. So if nobody wrote about the history that the events that have occurred, so then there's no proof that the event even occurred, right? So documentation is nothing but us noting down the progress we're making in the team, documenting it safely so that in the future it would be used. Let's say we won in 2015. We got the first place in 2015. We competed against the entire world, and nobody documented about it. So who would know Edhitha won in 2015? Nobody would know about us, right? So documentation is very important. There's a saying that goes, if you've not documented something, that simply means that never happened. So documentation is one of the very, very important tasks that the studio sub team will be taking care of. Moving on, event management. So events are obviously fun to sit and watch and enjoy, but to make it happen, make it really fun for the people experiencing it, the studio sub team will be taking care of event management, which is basically working off the stage. It could be planning of the event, it could be coordination during the event, it could be coming up with a lot of different creative ideas for the event. It could be any of it. So event management comes under one of the tasks of the studio sub team. Next, social media management. So those of you guys who have checked us out, checked Edhitha out on social media, you would know that we have a very huge social media presence. So why would we need an active social media us in reaching out to companies, right? So it would help us in getting in touch with the right people or right companies who could, in some or the other form help us, help the students. So that is why social media management is a very, again, crucial task that the studio sub team will be taking care of. All the videos and photos that they would be editing, they would be using that to manage the social media accounts. So why do you guys think it's okay? You guys are going to be like, okay, there's a tech team and then there's a non-tech division. Why do I have to join this? Like, that's why I asked the question: how many of you guys are interested in entrepreneurship? So being in this sub team, you guys are going to experience a lot. You guys are going to get a lot of good exposure to where you're going to understand the business aspect of how a team runs. It could be a startup or a business. The team runs in a similar fashion, and you would get a very good exposure to it. Obviously, you can add it on your resume. Who doesn't want to do that? You can add it on your resume. And other thing would be, how many of you guys want to do masters abroad or something? Oh, that's quite a lot of people. So you guys, if you guys are known by now, you guys might know it by now that you would have to write emails, essays, a lot of them actually. And this is where you can experience it, actually, improve on your essay writing or writing skills, any form of writing skills, or you can work on your grammar and stuff. And obviously, video editing is just super fun, like super fun. Like, imagine you guys edit a video and someone watches it and they're like, oh, this is a visual piece. That is how it should be. These are the things that you're going to get out of being in the studios, sponsorship and studio sub team. So anyway, that is it about studio and sponsorship sub team. This is what the sub team does. And now I would like to call upon stage the team leader, team captain of Edhitha. He's a very special person. Actually, he's one of the oldest members of the team. He's in fact my senior too, and he has helped us out a lot during the entire period of, when we came to Edhitha, we were just like, we didn't know things, and he was the one person we could go to and ask him how is things done. So he's also very enough about his introduction. I think it's better I call him on the stage. He's going to talk now. So he's going to be talking to you guys about why you should join the club, what to expect, the recruitment process, and he's going to also be talking about the prerequisites required. So I'd like you guys to pay attention, and yeah, thank you guys.
Thank you, Pratham, for that lovely introduction. Well, guys, so I would want to talk to you guys about a few things which I'm sure, now you got to know everything about the technical aspects and what we do and stuff like that, but now, as a fresher, there's a lot of questions which will be in your minds, which even I had when I would say sit in my orientations. So I'd like to clear many of them up. So first thing is, why join? Like why would you want to even do this? Like, you're not here to join club, right? You're here as an engineering student. You have courses, you have credits, you attend classes, you study, and you're here for that. So why join a tech club like this? So, well, in brief, I'll tell you what was it for me and what was it for a majority of people in our team. Passion, dedication. So, come on, it's drones, they fly in the sky, this is super cool. For most of us, including me, it started off as a toy. How many of you had a toy drone when you were small? How many uncle bought your toy drone? Yeah, majority of you. Yes, same thing for me. I think I was in 6th grade, 7th grade, something, my uncle bought me a drone. Super cool, yeah, they didn't fly properly, they never did. But yeah, that was what first launched this into your minds, right? Oh, okay, so because say when you were 2 years old, it was not normal to see drones flying, and when you were around 12, 13, around that time, you'd start seeing these drones. You don't want to read. You want to read? Congrats to the people whose planes landed on the stage. Your planes were very nice and aerodynamic to actually make it to the stage. We will be cleaning up the seminar hall and recycling these papers. That's it for the orientation. I hope you guys enjoyed it. Your recruitment form will be active on our link tree. You can get it in Insta bio, website, and all of those. And any of the existing posters, in case someone doesn't have social media, you can even scan the QRs on the existing posters. It will be updated in the same QR. So you can go ahead, fill our forms, and you'll hear shortly on email regarding the recruitment. So if you have feedback, do visit our lab and give us feedback about the orientation. Do DM us on Instagram. Any kinds of feedback, anything, everything's appreciated. Yeah, and anyone who wants to visit lab even now can just be outside. By the time we're done cleaning the lab, we'll be there. We clean the hall. We'll be there. Okay. If you can, then just any planes near your seats, just get them to one side. Thank you.
Yeah.
Depends on person how and very realistic. You have classes till 4:30, right? So after 4:30, you will see all our members stay up until 6:30. So many of our members stay up until 6:30. Then after that, depending on the workload, many times they stay till late at night. It all depends on because we work as a package. So that's how it works. So there's no real way to answer that question. But yeah, it's a lot of time you spend
Because I don't do anything about it. I'm good about it. So what would you advise me to do?
Have that dedication and that passion for it. If you are interested in it, don't try to fake it. It's autonomous. So if you are actually interested in that, then it happens. So don't stress about it. Now, if you are
amazing presentation, man. This was the best orientation I've ever been.
Your orientation was much better than the Excel orientation.
a former member.
No, I wanted to make the insult.
Fact is fact.
Which year are you?
I'm sorry. So, once again, if you guys don't know the picture, I want to have a picture. Okay, let's picture what?
We're doing it again.
Here, just come fast. Rina.
Sir,
On stage, come.
yes.